It's that time again, time for math. So if you were in the Zoom class this morning, you've already seen a lot of this, but even if you were, I've thrown in a couple of other features in this video. So I do recommend that you watch this. And this is meant to help you with the work that I've assigned for you tomorrow. So if you check your email on Friday of last week, you'll see that you got a big package of questions from Math Help Services. Check it out. And this video will go over what we did on Zoom to help you with it. So if you are not sure about anything, just pause it if you want, because I did go a little bit fast this morning. So this is everything again, so that you can go at it at a pace that you are comfortable with. So just to review, when we talk about area and perimeter, the idea of the perimeter is we are talking about a one-dimensional length, meaning going around a shape. So if the shape that we're talking about is a rectangle, like the one you see here, the perimeter is the fence, if it's a field, for instance, that we're going around. The area is the space that's contained by the perimeter, and it is a two-dimensional measurement. So I showed you this little animation before, and in the last math video, you can go check that out if you need to, that first of all, if we're dealing with the rectangle, finding the perimeter is pretty easy. If we know two sides, we're good to go. If we know this side is 4 and this side is 6, we know that this one's also 6, this side is also 4. We add up all the sides and we get that our total perimeter is 20 centimeters. To get the area though, just remember that we're dealing with a 2D measurement. So we can't use centimeters as a unit. We need to use these. In fact, when you're finding the area in centimeters squared, you're asking how many of these square centimeters can fit in a particular shape. And we're not using this. That again is just for science when we do volume. So for length, for volume, if I have this rectangle, you would see that I could fit 24 of these little squares inside. But of course, when you do this in math class, you do not do this by drawing little squares and filling it up and counting them. No, you do the base times the height to get this number, 6 times 4. And your answer comes out to be, like I said, 24 centimeters squared. Okay, so the big thing, don't forget this little 2. If you forget that and you just say 24 centimeters, you're talking about something that is 24 centimeters long. That is not an area. That is one-dimensional. So that's for rectangles. For triangles, this is the formula. It's the base times the height divided by 2. So I did this example with you in the last video and this morning. Just remember to be very careful that your base and your height must be perpendicular. They must be forming a 90-degree angle. Okay, so the base of this triangle is 6 centimeters. The height is not 6. I need to tell you that it is 5.2 centimeters. There we go. Now you can calculate the area. The perimeter just flashed on the screen, but it was pretty easy to calculate. Just add up all 3 sides. So anyways, the area, base times height divided by 2. You get 15.6 square centimeters. For this triangle, similar idea. You got to find out that what the base is. I'm going to say that this side is the base, 11. What's the height? Have I given it to you? No, I haven't. I have to show it to you. Well, there's the perimeter. Add up all 3 sides. But the height, I have to tell you this if I give it to you as a question, will be 8 centimeters. So same formula, 11 times 8 divided by 2. You're going to get 44 square centimeters. So that's a little bit of a review. Then what we did today is, well, I guess this is also a review because you've seen this before, the idea of working with the metric system. So first of all, be very happy that we have the metric system, because if we were in the United States right now using the imperial system with yards and feet and inches, we would have to do so much more math. It's crazy. So that's the good news. Anyways, you absolutely need to know these measurements in order. A lot of you told me this morning you've done this before, but you really absolutely have to know them in this order that they appear in. So I'm glad that you remembered the little mnemonic device to remember the order that they appear in. You may have heard of this before. King Henry died, mom didn't care much, something like that, to help you remember the correct order of these measurements. Or the slightly more inappropriate version that I was taught, King Henry's damn mother died chewing M&Ms. Whatever helps you remember them, you get to choose. Okay, by the way, remember their abbreviations as well. So if I give you a measurement, for instance, 5 kilometers, which would maybe be the distance between you and somebody's house, I don't know. 5 kilometers would take you a while to walk 5 kilometers. How many centimeters is that? I'm jumping ahead. Well, think about it. 5 kilometers is a pretty long distance. So it's going to be a lot of centimeters. Okay, so to get there, we're just going to do it one step at a time. We're going to go from kilometers to hectometers first. So we times it by 10 and we get 50. Then we're going to go to decameters next. Times it by 10 again, 500. You can probably see a pattern. Times it by 10, 5,000. So 5 kilometers is 5,000 meters. Keep on going. 50,000 decimeters, 500,000 centimeters, and finally 5 million meters. So if you say to somebody, I'm going to walk to my friend's house, it's 5 million millimeters away, you can say that. It's a little weird, but you can say it. Next, let's do this with maybe somebody's height. So you might be, for instance, around 1.6 meters tall. If you want to know how tall you are in decimeters, same thing. We multiply by 10. In other words, you just move the decimal over. So if you're 1.6 meters tall, you're 16 decimeters tall. You are 160 centimeters tall, and you're 1,600 millimeters tall. Again, just multiplying by 10 for every jump to the right. If I want to go to the left and find out how many decameters tall you are 0.16 decameters. Now we're dividing by 10 because we're going the other way. Whoops. Divide by 10 again, you get 0.016 hectometers and then 0.0016 kilometers. So once again, can you measure your height in kilometers? Absolutely you can. It's just really not convenient. But what I want you to think about is if you make a mistake, what if you accidentally multiplied when you were going this way? Well, this number wouldn't have gotten smaller, it would have gotten bigger. And what I want you to realize is look at yourself and see you're about 1.6 meters tall. You are certainly not 1,600 kilometers tall. The nice thing about this system is if you make a mistake and you visualize what you're dealing with, I'm hoping that you're going to see, whoa, that answer is way wrong. Okay, a couple more. We'll do this quickly. Just remember that every time we move a space to the right, we're multiplying by 10. Every time we move a space to the left, we're dividing by 10 when we convert. So if I give you 28.4 centimeters, that is 284 millimeters. And I'll just fill this out quickly. You can pause it if you want to try this yourself. And here's another example. And this time, as you saw this morning, I've switched it. I'm no longer dealing with measurements. I'm now dealing with volume. I've got this in liters. I'm going to convert it to milliliters, and maybe you've never heard of centiliters, deciliters, decaliters, but they all work. It's the same exact system. So same rule. This is going to be 20 deciliters, 200 centiliters, 2,000 milliliters. Keeping on going, 0.2 decaliters, 0.02 hectoliters, 0.002 kiloliters. Moving on, what if I give you a mass? Well, mass works the same way as well. All that I've done here is I've changed the M in kilometers to an L when we did volume and now to a G for mass. So same abbreviations, we just changed the last letter. And it works the same way. Times by 10 when we go to the right, divide by 10 when we go to the left. And here was one more example with pascals. These are units of pressure. So I told you, you don't really need to know this, but if you ever watch a weather forecast, you might see this number, 101.3 kilopascals. That's measuring the air pressure outside. Generally, the higher the air pressure, the nicer the weather is. That's why they include it a lot in weather forecasts. If you want to convert it, we're going to times by 10 to get hectopascals. You get the idea. We just keep multiplying by 10 as we go to the right. The reason that I'm bringing this back is because in some of the work that I've given you, it's going to mix and match units. It's going to give you one dimension in meters, another dimension in a different unit, in kilometers, for example. And you absolutely need to make sure when you were doing this that your units are the same? Does it have to be in kilometers? Does it have to be in meters? You choose, unless the question asks for something specific. But whatever it is, they must be the same. Don't ever forget that. So before I do any math or any calculation about perimeter and area, I am going to change this 800 meters into kilometers. If I made my little King Henry died chart like I did on the last slide, I would figure out that it's 0.8 kilometers. You need to be able to make that conversion. Be careful, don't go too quickly. So the perimeter, this is just a fancy way of saying I'm doing 0.8 plus 0.8 for this side, plus 2.4 for this side. This side is also 2.4. I'm just adding up all the sides and I'm gonna get 6.4 kilometers. Or if I want, I can leave this in meters and convert this into meters. 2,400 meters is 2.4 kilometers. Same thing, I'm gonna add up all four sides and I should get 6,400 meters as my perimeter. 6.4 kilometers and 6,400 meters are the same thing. So I got the same answer. Unless the question asks you for a specific unit, both would be correct. Same thing for area. We've got to make sure that we're dealing with the same units before we do any area calculation. So I'll work with this one. I'll work with them in kilometers first. We'll say that this is 0.8 kilometers and this is 2.4 kilometers. Well, if you remember, the area is just the base times the height. So I multiply the two numbers together and I'm going to get 1.92 kilometers square. If you forget that little 2, you are wrong. Other option, I can leave this in meters and convert this to meters, whichever way you want. 2,400 meters. So now 2,400 times 800 gives me 1,920,000 square meters. Same thing as 1.92 square kilometers. All right. We're going to come back to this though. There's an important idea with this. If you're looking at this and maybe noticing something, I'm glad. We'll catch that before the end of this video. Another concept I showed you this morning when you're working with different shapes or polygons as they're officially called in geometry is that we're going to use the word regular quite a lot. And if a shape is regular, it means that all of its sides and all of its angles are equal. It has to be both. So you already know this. This is an isosceles, what am I saying? This is an equilateral triangle. All three sides are the same. All three angles are the same. So we could say that this shape is regular. This is the isosceles triangle. Here, two sides are the same, but two of the angles aren't. So it's irregular. This is a square. All four sides are the same. All four angles are the same. So we're going to say that this is a regular shape as well. By the way, any four-sided shape is called a quadrilateral. That QUAD, quad, should make you think of the number 4. So regular quadrilateral, but we usually just say it's a square. And here are some irregular quadrilaterals. A rectangle. All four angles are the same. They're all 90, but hang on, not all the sides are the same. So it's irregular. This is a rhombus. All four sides are the same, but the angles are not the same. So this is not regular either. A parallelogram and a trapezoid. All of these quadrilaterals are not regular or irregular. So I showed you a couple of examples this morning. This over here is a trapezoid. It is irregular. It's an irregular quadrilateral because it's got different sides, different angles. This is a hexagon, and I really should have told you actually that all 6 angles are the same, but all 6 angles are the same, all 6 sides are the same, so it is a regular hexagon. We're going to make the same assumption for the stop sign here. All 8 sides are exactly the same. Every angle where I'm moving my little cursor right now is exactly the same. So it is a regular octagon. Octagon means 8 sides. This is the logo of the Dallas Cowboys. All sides are the same, but not all the angles are the same. This angle over here is very different than this angle. So because of that, it makes it irregular. It's an irregular decagon. A decagon is a polygon with 10 sides. This one, just because two sides are the same, not good enough. This is irregular because they all have to be the same for it to be considered regular, along with the angles. Don't forget. It's a pentagon because it's got 5 different sides. And then this one is a picture that I took when I was in Northern Ontario a few years ago. It's of a very large nickel. It's actually about maybe 3 meters tall. It's a big statue. Or I guess the statue is of a person. I don't know. It's a big nickel. Go see it in Sudbury. And what it's showing is the way nickels used to look. Now, if you look at a nickel that you have in your change, it's completely circular. But in the old days, it actually used to be a polygon. It used to have straight edges like what you see here. And they're all the same length, and they all form the same angle at each little corner here. So it's 12-sided, and it's regular. So the name for that is a regular dodecagon. Now, for now, you don't need to really worry about dodecagon, decagon, pentagon. It's good to know. But what I really want you to watch out for is the word regular and irregular. You're going to need to know it as you go through the math work. Then, finally, we got into how to calculate area for some different shapes. We know how to do it with rectangles and triangles so far, but what about parallelograms? Well, it's the same formula, base times height, as we were with the rectangle. Thing is that this would be the base. And remember, height has to be perpendicular. So I'm going to extend this to draw out the height. This side here, if I give it to you, is not the height. Be careful. Remember, height and the base must be making a 90-degree angle with each other. They must be perpendicular. Next, quadrilateral that I'm going to show you the formula for is for rhombuses. This is a rhombus. The way we find the area is we draw a line from one corner across to the other. This one is going to be longer than if we do it this way. So I'm going to call this a diagonal, and it's a long diagonal. So I'm going to give it a capital D. This one is the shorter diagonal, so I'm going to give it a lowercase d. And if I tell you how long these diagonals are, you can multiply those numbers together, divide by 2, and you've got your area. And it also forms a 90-degree angle where they intersect. So D is the large diagonal, lowercase d is the small diagonal. And then, last but not least, for trapezoids, the formula is a little bit longer here. And what I want you to know is that there's 2 bases. A lot of times people think base means on the bottom. I mean, it does usually, but this is also considered a base because it's parallel to this. So this base is longer, so I'm going to give it a capital B. It doesn't really matter which one is capital, which one is lowercase, but it makes sense to me that the longer one is the capital B, the shorter one is the smaller b, the lowercase b. And same rule for the height. This is not the height. This length over here is not the height either. I have to tell you the height, and it has to make a 90-degree angle with these bases. So large base, small base, and height. Add the bases together first. You have to do that first. It's in brackets. Then multiply the number that you get by the height, and then finally divide by 2, and you've got the area of the trapezoid. So you don't need to scramble to write these down. What I've also emailed you along with the work that I've left you is a formula sheet that gives you all of these formulas written out. They also remind you about perimeter for these shapes as well. But if you want to see this again, just rewind to the shape that you're working for in this video, and you'll be able to do it. But before we go, one more little thing that I'm going to throw in, and this is for everybody, even if you were part of the Zoom class this morning. I want to do one more example. What if you get a question where you get an area in, let's say, square meters? No problem there. But then you want to convert it into, say, square centimeters. Well, and what I mean here is you're doing this after you find the area. You're going to notice something. So I'll just give you a real life example to start with. I am going to bring up this soccer field here. So an actual real life FIFA or World Cup soccer field would be 120 meters by 90 meters. So what is the area of the soccer field? Not the perimeter. The area is pretty simple to find out. Just 120 times 90, and you're going to get 10,800 square meters. But if I want to convert that to square decimeters, for instance, if I want to go this way, do I times it by 10 like I did before? Close, but notice we're dealing with square meters. We've got the little 2 exponents everywhere now. So if I want to actually convert this to square decimeters, I've got to multiply it by not just 10, but by 10 squared, which you know is 100. So now, every time I make a jump, if I'm working with area, and again, be very careful, this is only if you're converting from one unit of area to another unit of area, you're multiplying or dividing, if you're going that way, by 100. So 10,800 square meters is 1,080,000 square decimeters. It's going to be 108 million square centimeters. Numbers are going to get really big here. And then for square millimeters, this would be like the worst way to measure a soccer field. It would be 10,800,000,000 square millimeters. Ugh. If you want to go the other way, to get it into square decameters, divide by 10 squared, divide by 100. It's going to be 108 square decameters, or 1.08 hectometers, or 0.0108 square kilometers. So I know I've continued to go a little bit fast here, but now that this is on YouTube, you can pause it and go to whatever point in the video you need. So keep this stuff in mind as you're working through questions 1 to 15 tomorrow, although maybe you're watching this today, yesterday, I don't know when you're watching this, but this is for the work that I've left you, questions 1 to 15 that I emailed to you last Friday. Again, you can check the formula sheet, and you're always welcome to email me if there's any questions. So that's pretty much it for now. Oh yeah, I just wanted to let you, yeah, some of you have commented that you've been experimenting with cooking, and which I'm very happy to hear. What a great habit to pick up during these pandemic times. Some of you have told me you've burnt whatever it is you're trying to do, so so have I. But the difference is I filmed it. I'm going to try to make a cooking video that would make Gordon Ramsay here proud. Of course, that's what he's really known for, right? For being a big fan of math and science. So just for fun, we'll shake it up, and I'm working on a little cooking video that I'll post to this YouTube channel next week. So keep your eyes tuned for that. So good luck with all the math work that I've left you. Good luck with the science work that I've left you. You can write to me if there's anything that you're not sure of. And as always, stay safe, stay inside. Well, actually, no, go outside. The weather is beautiful, but stay apart from everybody. You know how to do this. And of course, wash your hands when you come back in.